Good day everyone, I am Kaila at Maravilla from BS Bio 11. So for now, I will be showing to you the IUPAC names and structures of two functional groups in organic chemistry, which is the carboxylic acid and ketones. So starting with the carboxylic acid, it is any of the class of organic compounds in which a carbon atom is bonded to an oxygen atom by a double bond and to a hydroxyl group by a single bond. Simplest example of it is the ethanoic acid. Now let's draw the acetic acid structure. The key to drawing this structure is this COOH right here is what we call a functional group. It's actually a pretty common functional group in organic chemistry. So whenever you see COOH, you know it's going to look like this right here. We can attach that then to the rest of this up here, this CH3. So I'll put the C right here and the H's around it. In the acetic acid structure, we have 24 valence electrons. Let's count and make sure we've used them all. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24. So we've used all the valence electrons and we've used all the elements up here to make our acetic acid structure. Next up is the ketone. Ketone is any of the class of organic compounds characterized by the presence of a carbonyl group in which the carbon atom is covalently bonded to an oxygen atom. Simplest example of it is the acetone. This is the acetone structure, also called propanone. It is what we call a ketone. So when you see that O and E, we're talking about a ketone. And ketones will always be a carbon with a double bonded oxygen and carbons on either side. So by recognizing that, we're almost done with the acetone structure. So we have 24 valence electrons per acetone. We'll put our carbon in the center with our carbons on either side, with our double bonded oxygen. So we've used 3 carbons in the oxygen. We have 6 hydrogens that we need to put around the structure. So let's put them around the carbon. So we have hydrogen, hydrogen, and we'll put our 6th hydrogen right here. So we've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 out of the 24. Everything has an octet except oxygen. So let's put those last 2 pairs up here with the oxygen. Now we've used all the 24 valence electrons. Each of the atoms in acetone has an octet, and we're done. That's the structure for acetone.
Good day. I am Jamie Faith Alingig and I will be discussing to you the carbonyl group aldehydes. But first, what is a carbonyl group? A carbonyl group is a carbon and an oxygen connected together by a double bond. It has 2 groups, the aldehydes and ketones. An aldehyde is a carbonyl group with hydrogen attached on one side, and it is usually found at the end of a structure. Aldehydes such as benzaldehyde, which gives almonds their flavor and odor, cinnamaldehyde or cinnamon oil, and vanillin, which is the primary flavoring component of a vanilla bean. In naming an aldehyde, we use the suffix "al" if it is a parent chain and the prefix "oxo" if it is a substituent. So here in our example, we first count how many, the longest carbon chain. So this has 7 carbon chains, so it's a hepta, and the suffix "al", so this is called a heptanol. For the second example, we can see that there are three functional groups: the carboxylic acid, the alkyl halides, and an aldehyde. So in this structure, the carboxylic acid is the highest priority, and the suffix for this would be oic acid. So the first thing we need to do is know the positions. Since the carboxylic acid is the highest priority, the lowest position would be here. So 1, 2, 3, 4, 5, 6. Then let us now determine what are their positions. So since aldehyde now is a substituent, we will be using the prefix oxo. So this would be 6 oxo, and then 4 bromo. There are 6 carbon chains, so it's in hexane. And we don't need to put 1 on the carboxylic acid since it is the parent chain, but its suffix would be oic acid. So if we combine all these together and write it alphabetically, it would be 4 bromo, 6 oxo, hex, sanoic acid. Now let us draw the structure of 2-benzyl 4-phenyl hexanol. Benzyl it looks like this structure here, and phenyl looks like this structure here. It has the suffix "il" because both are a substituent. So what we first need to do is know how many carbon chains there are. So hex, it has 6 carbon chains. 1, 2, 3, 4, 5, 6. Then, since aldehyde is the parent chain, we know that it is usually at the end of a structure. So you can either put the aldehyde in here or in here. Next, we should put the benzyl on the position 2. So this is carbon chain 1, then this is carbon chain 2. phenyl will be on carbon chain 4. That is the structure of 2-benzyl 4-phenylhexanol.
Hello everyone, I'm Juliana Mica and I'm here to teach you how to draw and write the IUPAC name of Ester and Amide. In this video, we're going to work on naming Ester, and here is the example of the molecule to name. I can tell that this is Ester because I have here some R group, and in the middle, I have carboxyl group that is attached to an oxygen, and to the another R group. So, the general structure are carbonyl group which attached to an oxygen and attached to an R group is the ester. At this point, when we realize that it is an ester, I'm going to get this one so that we can go back to our original molecule. And because it is an ester, the molecule family name is O8. The next thing I'll do is to identify the carbonyl carbon, and these are the carbon number 1, 2, and 3. The next thing I'm going to do is to name the parent name of this molecule. As we can see, we have 3 carbons in the chain, and that is a propane. And when naming this, we're going to drop the E so that we will end up with propanoate. The next thing I'll do then is to ask what is hanging on the next R. Over here, hanging on the oxygen and the ester, which is the CH3, which is also the methane. So the substituent name essentially is the methyl propanoate. The next functional group that I'm going to teach you is the amide. Here is my molecule example of amide. And here we have a total of 3 carbons, which is associated with the word propane. And we are also going to drop off the E and add the word amide. This is called the propanamide.
Acid anhydride are derivatives from carboxylic acids. Acid anhydride are utilized in a wide range of chemical processes, most especially in composite materials. Phthalic anhydride and maleic anhydride are frequently found in paint, varnishes, and different kinds of plastic coatings. In naming an acid anhydride, all we need to do is add the suffix oic anhydride. So in these examples, all you need to do is identify how many carbon chains there is attached on both sides, then you add the suffix oic anhydride. So in the first example, you can see that has 2 carbon chains on both sides, so it is an ethane. Remove the E from ethane and add oic anhydride. So this structure is now called the ethanoic anhydride. This structure right here also, in principle, it is called a symmetrical structure because the 2 R groups are identical. Another structure right here, you can notice that the 2 R groups attached to it on both sides are different. In principle, this is called an asymmetrical structure. On how to name it, all we need to do is identify how many carbon chains there is on both sides, and then add also the suffix oic for the first group, and then oic anhydride for the second. Here, we can see that this is ethane and this is propane. If we write it alphabetically, this would be ethanoic, then propanoic, and add anhydride. A cyclic chain, instead of oic anhydride, its suffix would be dioic anhydride. So I will first draw a structure and then we will then name it. So in this structure, right here is the functional group acid anhydride. In naming it, all we need to do is count how many carbon chains there is and then add the suffix dioic anhydride. It's that easy. So looking at here, it has 1, 2, 3, 4, 5 carbon chains. That is pentane. And we only need to remove the suffix ane and add dioic anhydride. So this structure right here is called the penta-dioic anhydride. And that is how you name the nomenclature of an acid anhydride. Thank you so much for watching.